Hello everyone. Today we are going to see a problem statement based on data structures. Let's see it. Okay. Our problem statement tells us to find the shortest path distance between two or more locations, and it should be implemented using graph data structure. Let's see how it can be implemented using graph data structures. Okay. Then our objective of the project is to design an application based for calculating shortest path between two locations, and it should be implemented using graph data structure. Okay, our application will use graph data structures to represent the location and paths. Let's see the key feature included in our project. So the key features are shortest path calculation. Our application will calculate the shortest path between two different locations for analyzing the minimum distance and minimum cost or minimum traveling time. So the next key feature is the optimal route selection. Our travelers will be able to choose their preferred criterion for determining the optimal travel route. Then scalability. This system will efficiently handle a large number of locations and connections for providing an optimal solution. So, so we now see the graph. What is a graph? Let me explain. A graph is a data structure that consists of a set of vertices and edges. Okay, let's see vertices and edges. Vertices that represent the objects or entities. Edges that represent connections or relationship between the vertices. So okay, let's see the types of graph. Type: indirect graph, direct graph, weighted graph, unweighted graph. Let's see one by one. Indirect graph. In indirect graph, the edges have no direction. It means they can be traversed in both ways. Direct graph. In this, the edges have a direction, allowing to travel only in a specified direction. So, weighted graph. Each edge has a weight value, can be represent the quantities like distance, time or cost. Okay, unweighted graph. And in unweighted graph, edges have no associated weight, and that is the edges are treated equally. So, what are the applications of graph? Applications of the graph are route planning, social networks, network routing, scheduling, and resource allocation. So, next we are going to see Dijkstra algorithm for optimal travel routes. Basically, Dijkstra algorithm is an efficient algorithm for analyzing and calculating the shortest path between two or more locations. Let's see how it fits in our project. Graph representation. Here the nodes are here locations are represented as nodes, and the paths, that is the traveling routes, are represented as edges. Okay, then the shortest path calculation. Our Dijkstra algorithm will calculate the optimal route from a location A to location B. Okay, analyzing the path is minimum time, minimum distance, and minimum traveling time. So, efficiency. Dijkstra algorithm efficiently finds the shortest path in a graph, ensuring it can handle a large number of networks or connections effectively. So, user interaction. In Dijkstra algorithm, user can input a starting location A and ending location B with associated distance kilometers. So okay, let's see a real-time example. Here we have different number of locations from. Okay, each location has a start and an end point. So let's have an example of this. Okay, now I am going to travel from Madurai to Chennai and I have to find the shortest path for my travel. So let's see. So I am taking my starting location as Madurai, and I choose Coimbatore, which has a distance of 15 km. Then I will know my Coimbatore, and I will choose from Coimbatore to Chennai, which have a distance of 5 km. So so the final result will be the shortest path will be Madurai to Coimbatore and Coimbatore to Chennai. So the total distance covered is 20 kilometers. This is how we calculate the Dijkstra algorithm in program. Let's see how we can. Okay, this is the program for Dijkstra algorithm. It has okay. Let's see one by one. Okay, we have to include the header files. We define max number of vertices, max number of degrees, maximum integer type. Okay, and we declare two structures, one for edge and one for his graph. Okay, then we call a function read graph, which is used to input number of vertices and number of edges from the user. Okay, then this for loop. Okay, this for loop is used to get the location A to location B with associated weight values. Okay, then then uh, then the Dijkstra function. The Dijkstra function is initially set as 0. Okay, 0, and we get okay, and we are assuming the a start point and making it as 0. Then okay, then this for loop is used to calculate the shortest part between between different locations. Okay, between different locations, and this find part recursively calculate and recursively stores the shortest part from location A to location B. And hereby I can conclude that okay, this is the graph input, and this is the main function for invoking the above functions using okay. Then then the sample output will be like this. Okay, if I enter now six vertices and someone just okay, it prompts like this. We have to enter each edge from starting, ending, and with associated weight. So the shortest path it gets calculated like this. That's all.